My love for engineering started with something as simple as a box of Hot Wheels. As a child, I would line them up, race them around the perimeter of my bed, and would wonder why some cars were faster than others, and question their little shapes and details. At the time, it was my passion for toy cars, but looking back, it was the spark that made me start asking questions about design, speed, and small details, and how they could change performance. That curiosity grew as I spent more time with my dad in the garage. He wasn't an engineer, but he had a way of fixing almost anything, surrounded by tools, spare parts, and the smell of oil. And I would hand him wrenches, hold pieces steady, and would start to understand the logic behind each repair. The feeling of satisfaction to see how these things are taken apart and reassembled to just make it work really made me question how. The more I helped, the more I realized that I love not just the outcome, but it's also the journey of fixing it and the process of taking part and figuring out how it works. That's when I began to see engineering not as just abstract equations and numbers, but as a way of thinking and a way of creating solutions to problems. My passion deepened further during an internship at Toyota, where I explored how car mechanisms and engine systems are designed and optimized. For the first time, I saw how every system, electronics, aerodynamics, combustion, are interconnected to form something greater than the sum of its parts. What struck me was that most wasn't just the precision of the technology, but the way the people behind it worked together. Open minded, driven individuals combining their expertise into a shared vision. Engineering, I realized, was not just about solving problems, but it was also about contributing to a community that constantly challenges and supports one another. Even after the day officially ended, I often stayed behind to ask questions about how specific components were manufactured and how they operated at optimum efficiency. I was really fascinated by how each tiny decision, from material, design choices, tolerances, could ripple across the entire system. Well, immersing myself in that environment made me feel observe like not only was I observing, but I felt the true value of engineering. Not only the machines we build or how we build it, but it's the interconnection of ideas and people of the field of engineering and how that plays a large part of my passion. This this therefore has excited me and shown that engineering never stands still. It's always about pushing limits. From my recent experience in F1 schools, I've learned how ideas can evolve into designs that shave fractions of a second, how collaboration and persistence matter just as much as technical skill, and every setback became a lesson. Every improvement became a small proof that the skills and the thinking behind each design choices are from the mathematical and the physical laws of physics that governs them. And this reinforced the belief that engineering is just more about knowledge. It's about persistence, creativity, and teamwork. And I believe that the Komatsu Williams Engineering Academy represents more than an opportunity. It's the bridge between the curiosity that started with toy cars and my ambition to contribute to the innovations at the highest level of motorsport and engineering. I would be the first engineer in my family, and this academy would allow me to take a lifelong passion and turn it into a career where I can push boundaries and help redefine what's really possible. It will be the stepping stone of how I can make a difference to something that I truly love about. I experienced the power of teamwork and resilience most vividly when my teammates and I built a trebuchet for a science competition. The project demanded persistence through repeated failures and close collaboration at every stage, ultimately turning our combined effort into a winning design. For a science competition, my teammates and I were challenged to design and build a catapult capable of launching an egg as far as possible, while also ensuring a safe landing system and avoiding the use of metal. We began by sketching and modeling our design in Fusion 360, testing different arm lengths, pivot points, and release angles before moving to manufacturing with wood, drills, and screws. Well, every element from the stabilizing structure to the counterweight had to fit together precisely for the trebuchet to work. And what made the process especially meaningful was how much it relied on collaboration. My teammates and I divided responsibilities, drawing on each other's ideas, and even my dad played a pivotal role by mentoring me on the practical aspects of the build. There were many setbacks, release mechanisms that refused to trigger, structural components that buckled, and landing systems that failed. Well, yet, each failure pushed us to rethink, adjust, and refine. Eventually, the combined effort paid off when our trebuchet launched successfully, and we won the intercity competition against six strong teams. Looking back, what stands out is not just the result, but how interconnectedness the process was: designing, problem solving, manufacturing, and testing, all feeding into one another, each stage dependent on the rest. It showed me how engineering thrives when people share knowledge, bring different strengths, and push through obstacles together. That's exactly what excites me about the Williams Komatsu Academy. An F1 car is the result of countless people working across disciplines, designing aerodynamic surfaces, refining the suspension, developing lightweight materials, each component demanding excellence so the whole machine can perform at its limit. Success comes from persistence, collaboration, and the willingness to learn from your failure, and mentorship. My experience building the trebuchet gave me a taste of what interconnected process, and it left me eager to grow in an environment where teamwork and engineering excellence are at the core of every achievement. And that's why I believe that the Williams Komatsu Academy would be the perfect place for me to really delve into my networking skills as well as collaboration skills, and bring me to a whole new level of professionalism in this field of engineering. On the surface, the Williams FW46 and Komatsu HB365LC-3 belong to different arenas, yet both embody the same principle: pushing limits through precision and persistence. I experienced my own version of this during my extended essay for my IB diploma, where I delved into the complex phenomenon of liquid sloshing and fluid mechanics and set myself the task of mathematically deriving its motion. The complex research question that I aimed to investigate was finding how the percentage of liquid filled in a cylinder affected its time to roll down an inclined ramp. It was not a straightforward project. I could have stopped at a simple force analysis and get it over and done with, but I had the urge to actually dig deep and understand the governing physics phenomenon of this. I wanted to explore the problem the way real engineers and physicists would. That meant diving into undergraduate level mathematics and physics, from setting assumptions of boundary conditions to applying Lagrangian mechanics, and also use advanced CFD software techniques. I spent countless hours rummaging through research papers, line by line, teaching myself concepts like the Euler-Lagrange equation and seeing how it could describe the oscillatory motion of the liquid-filled cylinder rolling down a ramp. I tried to use the Lagrangian through my knowledge of conservation of energy, and eventually derived the equation of the system's velocity through a rigorous process of mathematical analysis. Well, though it sounds really difficult, it is often that my derivations broke down and that the equations gave a strange modeled answer. But this just makes myself even more stimulated to try again and find new approaches. Yet I kept going, reworking my assumptions, revisiting the conditions, setting new theories from new research papers that I found on the internet. When I finished this paper, what I'm proudest of is not just completing it, but it was also the process, the resilience it took to keep pushing when the math grew overwhelming, and the satisfaction that came when a difficult piece of theory finally just clicked. I discovered that immersing myself in this kind of rigorous, open-ended challenge brings me joy, and the joy of knowing I gave my all, of self-teaching, something daunting but rewarding, and of coming out stronger and more satisfied as I know that I've given my everything and I truly immerse myself into the rigor of the research challenge. That mindset of curiosity and openness to learning is exactly what excites me about this academy. Just as I push myself beyond the curriculum in my research, I want to immerse myself in a professional setting where every discipline is interconnected and every design choice matters. Motorsport is the pinnacle of this environment where engineering is not just a tool but a decisive factor that shapes performance, innovation, and success. What drives me is not only the chance to apply what I already know, but to constantly learn what I don't yet know. I want to surround myself with top world class engineers who bring professionalism, precision, and creativity to their craft, and to absorb the way that they think and question and just refine my knowledge. I see the academy as the ideal place to sharpen this technical skills, expand my perspective, and learn to collaborate within a community that thrives to push boundaries together. For me, the greatest satisfaction doesn't come from knowing all the answers, but from being in an environment where I can keep asking questions, keep tackling challenges I once thought were beyond my reach, and discovering new possibilities through other people's knowledge and teamwork. To be a part of a motorsport world where engineering is the heartbeat in every decision and where innovation is constant will allow me to not only push my limits but to grow into an engineer who contributes meaningfully to a collective pursuit of excellence. And that's why I believe that the Komatsu Williams Engineering Academy would be the bridge for me to really take this skill into another level and to give me the opportunity to delve into the field of engineering in such a top tier professional environment.